Welcome to the 2001 Professional Developers Conference. I'm Erica Wickers with the PDC News Update for Friday, October 26th. On this day in 1825, the Erie Canal opened. In 1863, the Worldwide Red Cross was organized in Geneva, and in 1914, Jackie Coogan, aka Uncle Fester, was born. The grand prize for the .NET head-to-head game has not yet been claimed, so we have a couple of hints for you. First, the algorithm for the cryptogram is known by two different names, both of which appear on your cards. The second clue, ASCII and you shall receive. This is your last chance to check out presentations by some of our great partners in Theater Room 411. Today's sessions include YouKnowBest.com, .NET Experts, WebEx Communications, O'Reilly & Associates, Adobe, and MyFamily.com. Please continue to check the housekeeping monitors or ComNet for detailed updates on session changes, as well as the schedule for repeat sessions. If you are unable to get into any sessions due to overflow, all slides are currently available on ComNet. We hope to have all general and breakout sessions available via webcast on ComNet in early November. PDC 2001 ends at 3 p.m. today. It's been a terrific week from registration to the Expo to the Windows XP launch and everything in between. This has been your daily PDC News Update. Now please welcome the host of the .NET Show and your host this week for the PDC, Robert Hess.
Welcome back for the final day of the 2001 Microsoft Professional Developers Conference. I don't know about you guys, but I've had a wonderful week. The whole day packed of keynote sessions we had on Tuesday, with the concert we had on Wednesday night, with the Ask the Expert session we had last night, and getting a chance to talk to you all people about what the technologies you're interested in, the sessions you've gone to, and all the .NET and .NET My Services capabilities that are coming out. We've had a great set of information coming at you, and while it's rather trite to say, the best is yet to come. Today, we're going to be talking with Rick Rashid, and he's going to show us some things that Microsoft Research has done. And myself, I think this is probably going to be one of the best general sessions talks we've had. We're going to see some really exciting things coming out. First out, I've got a couple announcements to let you know about. The head-to-head game, last I was told, no one has yet won it. So that cryptogram is still out there. At 2:30 today is the final cutoff. So if any of you want to take and make sure you get your final chance to solve the cryptogram, make sure you get it in before 2:30 today. In other game news, the Terrarium game, we've had over 2,300 entries, which is really exciting. Now later on, you'll hear more about exactly where that game has come out at and who the winner was. We also had a rescheduled session, a very important session. SVR 315 has been rescheduled for a second showing today at 9:30 a.m. in room 408B. This is the session on writing secure and hack-resistant servers. So if you wanted to get to that session yesterday and it was too full, you can come and see it again today at 9:30 a.m. in room 408B. And also, I've heard that the marketplace downstairs is having a fire sale today. So today being the last day of the convention, if there's anything you're winning down there, make sure you go down there, and if there's anything left, everything's on sale today. Well, hopefully, you'll all have a great time for the rest of the day today, a number of breakout sessions. But before we get to that, we have one final general session that I know you're going to enjoy. Thanks a lot.
gentlemen, please welcome the Senior Vice President for Microsoft Research, Rick Rashid.
Gosh, I don't usually get that much music before I give a speech. You have to really like those woofers, though. I don't know what it feels like to you, but I was really getting some chest reverberation from that. So what I'm going to do is I'm going to talk to you a little bit about the future, looking out. I know you probably have heard in the past, Bill Gates say that he has the best job at Microsoft. You heard Bill earlier in the week. Well, it's not true. He's been lying to you. I actually have the best job at Microsoft. I get to run the research organization. And our goal is really to sort of push the state-of-the-art forward and move things out. Now, we started Microsoft Research in 1991. In fact, we just held our 10th anniversary event. We date the beginning of Microsoft Research to the day I joined Microsoft. Since I came to Microsoft to start the research organization, and since I've been running it for 10 years, I can sort of date it whenever I want to. We've grown from basically one, that was me, and before coming to Microsoft, I was a professor at Carnegie Mellon for 12 years. To now we have over 650 people working in more than 40 different areas of research. And in fact, we've really spread out. We started in Redmond, but we now have research labs in Cambridge, England, in Beijing. In fact, I was just in Beijing for a tremendous event there. We have sponsored the largest academic conference in China. And we had an incredible turnout for that event. And then we also have a group in San Francisco. In fact, we just started one. It's not even on this slide. About 3 months ago, I started up a group in Silicon Valley in Mountain View. And we've got about 15 people there, and that's a growing group working with the .NET team in the Mountain View area. Now, one way of thinking about what my organization does is we're basically the Star Trek part of Microsoft. And in fact, those people who know me know that I'm a big Star Trek and science fiction fan, so it's not surprising I'd have a slide like this. What you're seeing in those two little videos on the side are MEMS devices. These are microelectromechanical machines, a few microns across. And one of the areas that we've been working in is nanotechnology and MEMS research. It's a little off the beaten path maybe that you might think of for Microsoft, but actually it's an opportunity for us to learn a lot about the underlying technologies that are going to create the next generation of devices. And it enables us to work with a lot of our hardware partners on new things to be developed. The holodeck, well, we're doing a lot of work in virtual collaboration. And in fact, you'll see a little bit of the work we've been doing in that area during my talk. We are working on language translation. And in fact, we have some very cool technology that we're going to be deploying internally later this year, where we're automatically translating our knowledge base articles. We're not quite at the universal translator level yet. I never have quite figured out how they can talk to people that they've never even met before, with all these other languages. But we're working on it. Currently, we're working on 7 different languages. The teleporter. Now, honestly, Microsoft's probably not going to be, building a teleporter anytime soon. But we actually do have a research group that's published papers in quantum state teleportation, which is the instantaneous transfer of state from one location to another, quantum state from one location to another. My joke about this is typically is that given, if Microsoft were actually to be the company to invent the teleporter, say 20 years from now or 100 years from now or whatever, that given our reputation in the press, the news articles that would come out would say, Microsoft copies again. That's just the way things go, right? The scanner, we have a lot of work that's going on in computer vision technologies. In fact, we have by far the most prestigious computer vision research organization in the world. And artificial intelligence has been a core competency for our organization from the beginning, and I'll talk a little bit more about that as I do my talk. Just to give you a feeling for the kinds of people that are working at Microsoft Research now, we have 3 Turing Award winners, Jim Gray, Butler Lamson, and Tony Hoare. Tony also recently won the Kyoto Prize, one of the most prestigious prizes in the field. Gary Starkweather, the inventor of the laser printer, is on our staff. Jim Splin and Jim Kajia, who both won Academy Awards for their work in computer graphics algorithms. Michael Friedman, Lassie Lovas, who's won the Goodell Prize. Michael Friedman's a field medalist in mathematics. Gordon Bell. And I put myself up there, I mean, obviously I'm giving the talk. I can do that too. But if you've ever heard the word NUMA architectures, I made up that word in about 1983. And if you've ever used Compact 264 Unix or the current Mac OS operating system, that's my code that I developed when I was at Carnegie Mellon. Okay, in terms of the philosophy, we're a funny organization. Our goal really is to move the state-of-the-art forward, and we're organized more like a university would be. We're very flat, we're very open, we talk about the things that we do. If you go to our research websites, you find out everything that we're working on. We're very aggressive in publication, probably one of the most aggressive groups in the industry in terms of publication. And we work a lot with universities. About 15% of my total budget actually goes into university research. And it's a significant part of what we do. We support fellowships, research grants, labs, things of that sort. Now, when I talk about the things that I'm doing as an organization, the key mission for us is to move the state-of-the-art forward. I mean, it's not, to make things happen for Microsoft. It's to move the state-of-the-art forward. And the reason that's the key mission is that unless we're able to move the state-of-the-art forward, unless we're doing the best possible work in the field, we're not going to be able to help Microsoft. Now, our second goal is to take the technologies we develop and move them rapidly into our products. And we treat that very seriously. I've got a team of people whose sole job is to do that technology transfer. And that's a critical component. Ultimately, what we're really here for as an organization, what we do within Microsoft is make sure that 10 years from now there will be a Microsoft, that our products are really going to have a future. If you look at what we're doing in terms of expanding the state-of-the-art, it's really stunning. No other research organization, as far as I know, has ever had numbers like this at conferences. At PLDI, which is one of the major programming language conferences that was held this summer, over 30% of the papers came from Microsoft. We've published more papers in computer graphics over the last 6 years than any other 2 organizations in the world. Just our research lab in China now publishes more papers in computer graphics than almost every other organization in the world. 13% of the papers at the Computer Human Interface Conference, SIGCHI, that was held earlier this year came from Microsoft. I mean, these are pretty unheard of kinds of numbers. We're pushing the state-of-the-art working with the academic community. So we're not just trying to push our research forward, we're trying to push other people's research forward as well. And this last year, about $75 million actually came from Microsoft and went into universities to fund education and research. So that's an important part of what we're trying to do as well. In China, I should just mention this as an aside, we actually give out degrees in China. We're the only Western institution that's been granted the right to give postdoctoral degrees, which is the most prestigious degree in China. And we're the only ones. And I think it's a statement about how far we've come as a research organization and the respect that we have around the world. In terms of the impact on Microsoft, I mean, the technologies we're developing have been a key part of what Microsoft's been doing. I mean, you've heard a lot of the things about .NET services and things of that sort. Many of the technologies that are going into these new round of products came out of our research organization. Historically, I mean, all the technologies that a lot of the things we've developed, I mean, I started the group back in 1994 that evolved into what's now the Digital Media Division. I ran the first electronic commerce group at Microsoft. A lot of the technologies that you see us coming out with today, whether it's the tablet PC, whether it's the streaming media, if it's things like the data mining support in SQL, all came out of our research group. So we're really pushing in a lot of those different areas. Well, that's a little bit about the research organization. What I'm going to focus most of my talk on, though, is not just the research group, but actually looking forward and saying, what's going to happen over the next 5 or 10 years. And what I'm going to be doing, in a sense, is telling you how we're going to try to break down what I think have been some of the key barriers that exist in our lives and our societies. I mean, one of the things that we're poised to do, I believe, is break what I call the reality barrier. To be able to use graphics, vision, and signal processing to be able to represent reality on computers. Breaking down barriers between people, allowing people to communicate better with each other, both in work groups, but also over distances. Barriers between people and computers, really making it easier for people to use computers, making it more natural, allowing people to interact with computers on their own terms, not on the terms of the computer. Barriers between people and information, making it possible to really understand the tremendous amount of data that we're now able to collect and hold. barriers between computers, really breaking down barriers between computers and allowing us to build what is really a large global distributed systems infrastructure. And barriers between different aspects of people's lives. If you think about the things that you do personally, you've got the things you do in your office, the things you do in your car, the things that you do when you're at home, the things you do when you're out at play. How can you bring all those things together and break down those barriers as well? Let me just talk about some of the technologies that are enabling the changes that are happening. On the one hand, you have the tremendous change in graphics. I mean, you all know about Moore's Law. Moore's Law says that the processors increase in speed, about a factor of 2 every 18 months. That's a factor of 10 every 5 years. It's a factor of 100 every 10 years. All right, well, that's good. But what's really been happening in the computer business over the last few years is that all the other technologies around the processor have really been increasing in performance much faster than processor technology has. In the graphics area, for example, we've seen in the last 3 years more than a factor of 100 improvement in real-time computer graphics. I mean, we've gone through generations of machines. I put some of the old boxes for graphics cards up there. I mean, of the Voodoos. I mean, that company doesn't even exist anymore. I mean, the tremendous change that's occurred over the last 3 years has really been astonishing. If you look at storage, over the last 4 years, we've seen a factor of 8 improvement. It's averaged more than a factor of 2, or about a factor of 2 every year. That's, again, enabling a tremendous number of new applications, and I'll talk about that as I go along. And the networking area. We've had a tremendous run-up in network performance, especially wide-area network performance, where now you're able to talk about multiple gigabits per second over 5,000 kilometers. But we're actually poised to go much faster than that, and I'll talk about some of the technologies that make that happen. If you think about new technologies that are on the horizon, it's actually mind-boggling. Some of the things that are happening right now with nanoscale materials and processing are just stunning, just absolutely stunning. Being able to do things like build single-wall carbon nanotubes and think about the kinds of applications that can be built around that. Electro-optical circuits that can be built with organic materials that let you do things like switch networks at over 100 gigahertz or 100 gigabits per second. I mean, these are technologies that actually already exist in laboratories. So they're not even speculative at this point. People have already demonstrated an ability to use the wave division multiplexing to run wide area networks at terahertz speeds. So these are technologies that you're going to see having a tremendous impact over the next 3 to 5 to 7 years, and are going to completely revolutionize the way we think about building computers. Now, I mentioned breaking down barriers. I mean, one of the barriers that I mentioned is the reality barrier. I guess it's appropriate to talk about movies here since we're in LA. If you think about the original Toy Story movie, each frame of that movie was built up about 2 to 12 million triangles. So if you understand how 3D graphics work, effectively the tessellated surface of the objects that you were seeing on the screen, the sum total of those triangles was about 2 to 12 million. This year, this Christmas, with the Xbox console and with the graphics cards that are coming out on the PCs, we'll be able to drive over 150 million triangles per second. What that's really saying is we're at the point now where we actually could create in real time the kinds of graphics that you saw in a Toy Story. If you think a little bit farther into the future, Alvy Ray Smith, who's one of the founders of Pixar, and has worked at Microsoft, he and I were talking about sort of what would reality be. His back of the envelope calculation was that roughly speaking, he felt it was something on the order of 80 million triangles could represent sort of the image that you see before your eyes. Within the next 5 and certainly 10 years, we'll be at the point that we could literally represent in real time on a PC the kind of reality that you see when you look out your eyes or through your picture window, and do that on computer displays. And of course, the display technologies are improving dramatically at the same time. So there's really a tremendous amount of change that's going on. Now, to give you sort of that's a way to talk about it, to give you kind of a visceral sense of what we're talking about here, I have Drew Angeloff from the Xbox team. He's going to come out and show you a little bit about where things are on the Xbox.
Thank you very much. So before I start, I wanted to talk a little bit about the Terrarium contest. I just got an update. Apparently we have a winner of the Terrarium contest, which I will announce. And in addition, this weekend, they're going to restart the database and throw all your creatures in, all 2,300 creatures. And the first herbivore, or the number one herbivore and the number one carnivore, will actually receive signed T-shirts from Bill Gates. So the winner of the randomly drawn creature that actually won, and the winner is Zhenyu Yang. And actually, I should probably mention, Zhenyu, you should probably come here afterwards if you actually want your Xbox and 6 games, so after the keynote. So I'm actually not up here just to talk about Terrarium. I'm actually up here to talk a little bit about Xbox and sort of how it's established the future of gaming in the living room. Xbox there's basically 3 things I want to talk about. The first one is hardware. So actually, Rick talked a little bit about how the hardware in Xbox works. It's custom NVIDIA chip. It can do 150 million triangles per second. It can get up to 4 gigapixels per second of fill rate, which is astronomical if you actually think of how many pixels that's drawing per second. 4 gigapixels, that's a ton. In addition, there's other parts of the hardware that are definitely leading in the console industry. We have audio hardware that does 256 channels of sound, which I find offensively way overdoing it. In addition, it can do 64 3D head-related transfer function voices, or it can do 64 Dolby 5.1 encoded in real-time voices. In addition, probably my favorite feature is that we actually have a built-in hard drive and an Ethernet connection in every box. So that means our developers know that that hardware is actually going to be in the box, so that it's truly the online console of the future. In addition, I want to talk a little bit about software. Our software solution, let me start out by saying, basically we have a mantra at the Xbox team, and it's to make game developers heroes. That's really what we're trying to do, is we're trying to make game development easy, and instead of spending your time fighting the hardware, what you really want to do is you want to give developers a chance to make the game fun, make the art good, make a great story, entertain people, instead of actually spending your time fighting the hardware. So we've done a few things like debugging on the Xbox is exactly like debugging a remote PC. So you say, compile, set a breakpoint, run through some code. It's remote debugging. It's remote debugging. It's easy. And actually, Rick talked a little bit about research. That's another area where we really have, we've basically exploited Rick's guys. In fact, we even stole one of Rick's guys, Jed Langell, who actually did a fur shader. He'd done a lot of fur rendering techniques, and I believe he wrote some SIGGRAPH papers actually when he worked for you on the fur technique. When you get your Xbox on November 15th and you're playing Tony Hawk 2, that grass, the grass that is fully deformable, that's actually Jed's research that went into making that grass. In addition, he stuck his grass into NFL Fever and a couple other titles. And this basically, it's just representative of how once you build the hardware and once you have completed software, the game isn't over. We still are trying to figure out what are the best optimizations. How do you best do security? How do you best do games on the network? How do you make fur shaders and grass shaders, and how do you best do that? And then we deliver that information to third parties and first parties completely free of cost, just to make our platform a little bit better, to make our games great. So I've been babbling a lot, and I think that I think you guys actually wanted to see a little bit of Xbox. First, maybe I should give you a little background on what I'll be showing. This is going to be DOA 3. It's by Tecmo and Team Ninja. Yesterday, we had a rehearsal at about 5 o'clock, and I'll tell you something. I was actually going to look for a guy to take a dive so that I could win, because that's the way I am. So they looked around. I said, well, who's a good guy? Who's basically the worst gamer that you have here? And everybody goes, oh, Paul Nyborg. And I'm like, oh, okay, well, I don't know who this guy is. So could I introduce Paul? Could you come out? Paul is a jerk because he beat me. He comes out. He has no console gaming experience, and he beats me soundly in a game. So this is actually, maybe it's a demo, but it's also just an amazing grudge match, because if I can't go back, I can't go back to Xbox with this guy actually winning.
There's a lot of money riding on this. So.
Yeah. Oh, that's the other thing. There is a lot of money. So if you should be suspicious. If I actually do take a dive, we're probably splitting the profits, no doubt. So there you go, Paul.
Okay.
Paul is Brad, and I am Lei Fang.
Excellent.
Thank God. Otherwise, they
Excellent.
would have fired me if I hadn't won that. Thanks a lot. Thanks, Paul. Thanks, Rick.
Thanks a lot, guys. I can tell I'm going to have to get better woofers at home. I've got my Xbox coming. I don't know if you guys have all ordered yours or not. Gaming's always had always been close to my heart. Back when I was a graduate student in the 1970s, I did one of the very first network computer games for the Xerox Altos. It was, of course, a Star Trek themed game called Alto Trek. And just last year, Microsoft released a game that I developed, which was a massively multiplayer internet space action strategy combat. I think I've left out some of the buzzwords for it, but it was an interesting product as well. Now, gaming is one way you can think about using this kind of graphics and representing reality. But there are other potential uses for it as well. Here's just here's your typical flat picture of me. There's nothing really much about it. It just sort of sits there. It doesn't really do anything. But you can use this kind of graphics technology to create a little bit more realistic kind of model. All right, so there's more of a 3D version of me. Now, this is interesting technology because this is done by some people in our computer vision and graphics group. And the way you create this kind of an image is they simply took a regular digital camcorder, nothing special, run it across your face once. The whole process takes 30 seconds. And then they extract from that information that lets them recreate the three-dimensional image of your head, and also to steal all the appropriate textures and place it in the right locations. Now, unlike that flat image that I can't do anything with, this one I can actually play with. For example, you can make yourself smile. It's kind of a sickly-looking smile, but it is a smile. You can make yourself very sad. People really, especially people who work for me, they don't really like to see me very sad. But if you want to be sad, I think for a Microsoft executive, I think this next feature is probably the most important. You can pretend to be thinking, and this is something that would serve you really well, serve me at least really well in a lot of meetings that I go to. When I'm really thinking about something completely different, but I can pretend to be be thinking. Now, of course, I mentioned my interest in science fiction. You know, if I wanted to look a little bit more like Mr. Spock, you know, I can do that. Somebody said it looked a little bit like Bill Nye the Science Guy. I'm not sure about that. But on the, if your interest in science fiction goes a different direction, you can be more like an E.T. At the end of the day. And of course, when I did this, I had my contacts on. I've got glasses on today, so you can always add those glasses afterwards and get a chance to play with that. So that gives you a sense. I mean, if you think of the ways in which this kinds of technology is going to be used, I mean, increasingly, you know, people are going to be using technologies like this to really be able to represent things that are in the real world, but allow people to interact with them. We're working with MIT, for example, in building virtual laboratories, chemical laboratories, mechanical laboratories, and so forth, using technologies like this and allowing students to do the things that they may have done with the physical laboratories, but now they can do them a lot more safely. They can do them from remote locations, potentially, and they can learn a lot more because they can do a lot of experiments that would just be too expensive to do in real life. So there's a lot of ways in which these kinds of technologies are going to be used. Now, I've talked a bit about graphics. There are other technologies that are associated with creating real things. One of those are sounds. And what I'm going to do now is play you a little clip of work that we've done to basically allow us to create very like-life text-to-speech systems where we're able to effectively extract from an individual the sound of their voice and to be able to effectively recreate that by simply typing in text. So what you're going to hear is a series of sound pairs, a synthetic voice and the real voice from which the synthetic voice was derived.
Various automatic trained voice tables. First, synthetic voice. Second, original recording.
The meeting had scarcely begun, then it was interrupted.
So that's synthetic.
The meeting had scarcely begun, then it was interrupted.
That's the real person.
He spoke to various of the members.
That's synthetic. You can hear a little bit of
He
them.
spoke to various of the members.
That's the real person.
However, the aircraft which we have today are tied to large, soft airfields.
That's synthetic.
However, the aircraft which we have today are tied to large, soft airfields.
So that was the real person. The weird thing is that guy sounds just like a computer. Now I asked the guys that in our speech team, you know, like, why did you? I mean, he's a voice actor. His name is Mark. I asked, why did you hire this guy? He sounds just like a computer, you know. And I thought, you know, maybe this is his acting voice, right? This is his professional voice. And I met the guy one time, and he sounds exactly like that. I have no idea why they hired him. But, you know, what the heck. Now, what you've got here, you can take that. In that case, in the sounds I just played for you, we were using basically human prosody, okay, to effectively give the lilt to the voice. So human prosody is sort of the music behind the human voice. But of course, you can take real music and put that behind the voice. So what I'm going to show you is sort of the effects of effectively taking MIDI music and using that as the prosody. So it's a text-to-speech where basically you type in the text, and then you put the MIDI music score on top of that, and then you'll hear what you get. And to give you a contrast, the first, I'm going to play a little piece from the 1962 very first system that was done at AT&T, which, by the way, was a tour de force. I mean, it's amazing they were able to do this in '62. To give you a sense of, you know, what artificial singing was like, you know, in the early days. It was pretty bad and was also loud. So that gives you a sense of what you can do if you simply put this to music. That was the Mark voice, by the way, but done to music, so it sounds a little bit better, not quite as computery. Now, you get a couple of things out of hearing something like this. You know, first off, it's completely clear that this technology does not threaten Simon and Garfunkel. You know, we're not at the stage where we're going to be going out there competing with real people singing. But we're starting to see, I mean, you're starting to get to a point, though, where you can see over the next few years that there begins to be a possibility of capturing the way someone talks, the way someone sings, and then being able to sort of keep that and recreate it into the future. Much like the technology I showed you of my face, you could imagine using a technology like that to capture, say, your children, you know, when they're small, an infant. I mean, I've got a 1-year-old and a 2.5-year-old at home, and it's interesting to think about being able to capture what they were like in a lifelike way and be able to carry that forward into the future. Now, another barrier that we talked about early on is this notion of breaking down the barriers between people and computers. And there we're talking about creating technologies that allow us to interact with the computer on our terms rather than on the computer's terms. I mean, fundamentally, when people talk about user interfaces in computers, they're not talking about user interfaces. They're talking about computer interfaces. These are interfaces designed to enable the computer to work better, more so than to allow a person to work better. I mean, I know, going back to the 1970s, I mean, I worked in some of the early windowing systems, you know, and if you go back to some of my old papers and papers of my colleagues in those days, we talked about multiplexing the user, right? You know, allowing the computer to operate more effectively by having the person do more than one thing at a time. And well, I mean, that was important back then. Computers were expensive. We didn't have a lot of processing power. Now we're able to use processing power to really enable a new class of applications. So seamlessly integrating ink, handwriting, generalized support for gestures, integrating speech recognition and support. These are all some of the technologies that are really going to make this possible, really make this make sense. Now, to give you sort of, again, a visceral sense of what I'm talking about, I've got Bert Keeley, who's going to be coming out from the Tablet PC group, and he'll show you a little bit about sort of what mobility and natural forms of input and gestures can do to really create a better experience and new experiences using the tablet. Now, you've seen a little bit of the tablet, but you haven't seen this particular demo because it's the first time I think we've ever shown it. And Bert's going to come out, and he's not only, he was in Microsoft Research, he's now an architect in the Tablet PC group, and on top of that, he's a musician, and he's going to show you how you can create music with a tablet.
Thanks, Rick. Good morning. For those of you who haven't seen a tablet PC this week, this is one. In fact, this is the unit that I've been using for the last 11 months as my primary PC. I can tell you that the mobility is really liberating, and it's not just that you can have all your information with you all the time, but you can use it just about anywhere. Just yesterday, I used it for about 45 minutes, I think, while standing in line for airport security. But today, what I want to show you is the way that gestures, pen gestures, can be used in a specialized application. And to do that, we have an application which is for writing music, okay? And this app was written by a team at Brown University, led by a fellow named Andy Forsberg, written in about 6 weeks using the Tablet PC SDK. So here's his app called Music Notepad. And we know that Rick's a Trekkie, and so what we decided to do was write out the Star Trek theme. And to play that, I can just write a P. That's not Star Trek, that's Star Wars. Okay, so what I get to show you is how to start from scratch writing music out. We need the Star Trek theme. Some of you may know that Rick has been taking his team out to see each Star Trek movie as it gets released. And at this point, he has to rent out a whole movie theater on his own nickel to do that.
Yeah, it was actually started very innocently. I mean, back in 1980, I only had 2 graduate students working with me, you know, so I could afford that pretty easily, but it's gotten kind of expensive since then.
Let's see if we can put a plug in for him taking everybody at the PDC to see the next Star Wars.
That's okay. It's going to be a long time before the next Star Trek movie, so
Okay, so what I can do here for writing music, first of all, I'll use a gesture that's very popular on a tablet PC, which is called we call a scratch-out gesture. Okay, and you can see what happens there. It just gets rid of all the notes, gives me some room in which to write. Here, I'll zoom in a bit. Okay, now to write music on a tablet is as simple as this. Write a note, give it a stem, write a whole run. Let's see where we are now. P for play. Okay, that's getting closer, right? But we've got a little bit of work left to do. Need to increase the duration of that note. Need to change the rhythm of this section a little bit. Increase the duration of that note. Sharp that note. Sharp that note. There we go. So that's what it's like to write music on a tablet PC using gestures. A great part of the natural input methods of the tablet PC. So we also have, thank you. Thanks to the folks at Brown University. Now, the tablet PC input architecture also supports, as most of you probably know, great speech recognition technology and handwriting recognition technology. And to show you how those two work together in a multimodal fashion, we'd like to have Rob Chambers come out. He's the dev manager for the tablet PC recognition group. Rob?
Captain's log, stardate 2324.9. New paragraph. My communications officer has just informed me that there was a mix-up regarding Star Wars music and Star Trek music in the previous demo. Now, as you can see, it did a pretty good job of recognizing the words that I spoke. In fact, there are only a couple of mistakes here to correct. So let's pretend that instead of saying mix-up, I had actually said problem. I'll show you how using the power of the pen, along with speech, creates a rich input experience on the tablet. I can simply select a word that I want to correct, click on the correction widget to display a list of alternatives. In this case, it's really confident that I said mix-up. So let's say I said the word problem. Scratch-out gesture works here as well. I can also use the same correction user interface to correct capitalization mistakes, such as in Star Wars and in Star Trek. Once I have the text exactly as I'd like it, I can go ahead and send it to the application. In this example, that's Notepad. Now that you have a feel for what the exciting new natural input technologies look like on the tablet, let me show you what we've also added for speech command and control. File, save. My Star Trek log. Send text. Save. Yes. Close. Now, the most important thing to note here is we didn't change a single line of source code inside Notepad to enable this great dictation, handwritten text, and command and control experience. So everything that I've shown here today will be available for all applications that run on the tablet automatically. Let me show you what you as developers can do to make the user experience even better by allowing the dictated text and handwritten text to go directly into your applications. Start WordPad. This version of WordPad is using a new version of the Rich Edit text control. which itself is using a new technology called the Text Services Framework. Captain's log. Stardate 2327.5. As you can see, the text went directly into the application and was preceded by an indication as to where that text would appear in the app. Also, the correction user interface is available in place in the application. So by incorporating the Text Services Framework directly into your applications, or by using controls that are part of the tablet platform that already incorporate this technology, you can enable the user to have a much more seamless experience when using natural input technologies inside your applications. Thanks.
Thank you. You know, I'm actually kind of amazed this demo even works. There's a tremendous echo on this side of the stage. So it's a testament, I think, to the quality of the recognition and also the close talk mic that he's using. The interesting part about the speech technologies are really getting very, very good now. To give you a sense of how good they're becoming, in China, with the release of Office XP, the Chinese speech recognition engine now is probably the fastest way to get input in Chinese into a word processor. In fact, one of the guys that heads up the speech group was in China recently giving a speech at Tsinghua University. And some of the students in the audience, he said that, and some of the students in the audience challenged him on that. So he asked them on stage to bring the fastest typist up, and did an on-stage challenge where he used the voice input, and it was a woman, and she was doing the typing, and he beat her by a significant margin. So I think it's a statement again about how good some of these technologies are becoming. Now, we talked about different kinds of input. I mean, one of the key technologies that you have to have to really begin to interact intelligently with people is natural language technology. You need to be able to interact with people on their own terms. Now, going back to Word 97, in Office 97, we began to introduce natural language technology from our research group into our products. Now, the initial use was in that little green squiggly underline thing that you've seen in Office, what's called text critiquing. Underneath the covers, what's actually happening in Office, and it's gotten progressively more sophisticated with each release, is that it's actually, in effect, doing the kind of grammar charting that you remember from grammar school. Here's an example of a sentence, and it's really, in fact, there's a DLL in Office that will actually produce this output if you know how to use it. It's mostly just used by us internally for debugging. But it gives you a sense of the kind of information that we're gathering. And it's not just about the syntax, but we're also beginning to gather semantic information. You see what's called the logical form at the bottom there. It's really able to figure out that in this case, that Motorola is the subject, that chip is the object, and diagnostic is the adjective that's affecting that. And we're even able to figure out which meanings of words you might be using in a particular sentence. Now, we're using this technology all sorts of different ways within the company. It's being used, for example, in Windows XP in something called the Search Companion that exists in Windows XP, where it's actually using natural language technology and some AI technology we call support vector machines to be able to effectively recognize when you type in a search query whether you're attempting to perform a specific task. And I think it currently supports about 700 different tasks. And if it recognizes a task that you're asking to perform, it will then step you through a wizard to try to do that for you. So if you start asking a question about a movie star, it'll step you through a wizard that helps you either find out how to send fan mail to the movie star, how to find out when the movie star is going to be in your town, how to find out more information, and so forth. So that's the kind of support that's in our systems. We're using it in a lot of other ways. One of the things that we're able to do is effectively build a database of English text material. This is something we call MindNet, where we actually use our natural language technology to effectively read English material and construct on the fly a database, a relational database of that information, or you might call it a semantic database of that information. To give you a sense of what that looks like, here's a segment of a database that's been constructed around the word bird, where what we've done is read a dictionary. And it gives you a sense of how much information you can extract from English text. In this particular case, the dictionary is actually telling you that a chicken is a bird, that a quack is caused by a duck, that a quack is a sound, and so forth. I mean, this is information that we've extracted simply by reading a dictionary. There's no human being involved in creating this kind of a database. And we're increasingly using technology like this in products like Encarta. We're using it to do things like data mining and various kinds of data analysis. So things like that. And one of the areas that we've been experimenting with, and I'll now switch to a demo, is using this kind of technology to do things like question answering. So everybody's used to the concept of using a search engine. But search engines, you think of them as information retrieval, but in some sense, they're not doing a very good job of that. They're more like document retrieval, right? You type in a query, and you get back not the answer to your question, but instead you get back a list of documents which may or may not be the things that you're looking for. Well, one of our researchers over the last 6 or 7 months now has been trying to develop technology that effectively uses the web as a knowledge base, but instead of responding to a query with just a list of articles, it attempts to respond to a query with an actual answer, right? So you can type in something like, what color, if you can type, of course, grass. And what it's going to do is it's going to reformulate that query using natural language technology, go out onto the web, and in fact it's doing it in real time, go out onto the web to try to find what appears to be the right kind of an answer, and then in effect summing up all the information from the various articles. It tries to give you what it thinks is an approximation of a good answer. In this case, it actually comes out with green. That's not always true in California, but in Seattle, grass is mostly green. You can ask it all sorts of questions, and we've actually done blind studies of this thing so far. We find it gets about 60% of the answers right for arbitrary questions, which is, it's not as good as you'd like it to be, and we're continually improving it, but it's remarkably good given the breadth of questions you can ask. Unlike something like an Ask Jeeves, there's no information programmed into this system at all. It's simply going out on the web. So if you say, who is the so going out, again, it's just going to look out on the web, try to find what it thinks is the most appropriate answer to that. As it thinks. Actually, it's actually doing queries right now. I don't know what just happened there. Let's try this again. No, it doesn't like that one, which is weird because it was doing it just yesterday, but it may just be that it's having some trouble getting to the search websites. Yeah, no, it actually does a pretty good job of finding articles that it thinks are appropriate, but it should have come up with the answer. Somebody just said that yes, it did come up with the right thing, sort of. Let's see if it gets this one. It's a little funny because the fact that it's going live out on the net all the time means that you never quite get the same exact answer each time you do something of that sort. No, it's unhappy for some reason. I'm not sure exactly why. Maybe it's just lost it. Let me just restart it here. Let's see if that does anything for it. Because it also looks like it's not. Yeah, it looks like it's not getting the things. Now let's try it again. It worries me that it's not putting up all the pictures either, so maybe it's lost its network connection or something isn't working quite right. Because if it's just if it's just going out for cached data, it's not going to work. No, there's something wrong. I'm not sure what it is, but it's not getting the, maybe it's lost its network access or something of that sort. The interesting part about this, when it does work, is that you can play around with it doing all sorts of things. And I'm sorry, but I can't actually seem to be able to show it. For example, I mean, I've typed in a bunch of different kinds of queries into it. And, oh, internet, right. Okay, there's just a message on my screen saying, internet is down. Okay, that's why I can't get it. I love these little messages. I was hoping it, as long as it doesn't say the building needs to be evacuated, I guess we're in good shape. It's also flashing. When we have access to the internet and it's actually working, the kinds of answers you'll get, for example, if you say, when did Abraham Lincoln die? It'll come back and it'll give you, I think it's April 14th, 1865. When you say, when was he shot, you'll get April 15th. He died on the 15th, he was shot on the 14th. But what's interesting is if you actually go out onto the web, you'll find articles that have those dates wrong. And so in fact, it's the preponderance of information that it's looking for, not just the fact that there is a website out there that has that. We were playing yesterday with this application, and somebody typed in, where is Osama bin Laden hiding? And it came back with hidden fortress in Afghanistan. I have no idea how it got that, where it was getting that from. Another thing that I typed in just for fun was who was that masked man? For those of us who remember back to the old TV shows. And it came back with the Lone Ranger was the #1 answer, and Clayton Moore, who of course played the Lone Ranger, was the second answer. So I thought that was amusing. I'm sorry that the internet's down. We won't be able to show you that in more detail. But it is a really cool system, and it gives you a sense of where we're going to be able to go with these kinds of technologies in the future. Now, I mentioned breaking down barriers between people. This is particularly important because I know you all know in your jobs, you always have to work with other people. There's always a work group setting, and often you're not in the same buildings or you're not in the same location as the other people that you're working with, and so you need to be able to get ready access to them. One of the technologies that we're using, we developed within research, and that we're actually using in research, I mean, I use this on my machine all the time, is something called Sideshow. It's a very simple idea, but the idea is to really create what effectively is a notification bar, which in this case is on the right-hand side of my screen, right-hand side of your screen there too. And on this bar, you can put a lot of different kinds of objects. I mean, basically, these are all sort of ActiveX, COM objects that you can drag into this bar that represent various things. You can, for example, I mean, this is an example of someone who has effectively their work group in their Sideshow bar, where there's information about their mail, their schedule, the people that they're working with, and the ones that are looking away are not in their office. The person that's looking toward you is in their office, and they get this information from just the typing that people are doing on their computers. There's information about directory that people are sharing with each other. There's a RAID database, which is where we keep our bug information that's represented there. And then you can put fun things on there as well. You can put eBay auctions, you can put Amazon. If you want to keep track of the news, you can put the news or weather or sports. Here's just an example of the kind of information that's there. And here's another example. We have these things called tooltips. Now let me actually bring up the, let's see if it's, I think this will be back on this machine again. Yeah, here we have Sideshow running. And again, we're not connected to the internet, so things aren't really live here, I'm afraid. But if they were live, they'd be constantly updated. And I don't have access to the mail because we're not connected. But you can see, for example, if I move the cursor over the weather, I can find out more detail. We call this sort of an extended tooltip. Here's stock information. So NASDAQ is down, Dow is up, or at least it was before the network went down. Microsoft is up a little bit. That's always good. This is my wife. If she's online, I'll see her picture. If she's offline, I have this inverted image. You can make the online, offline look whatever you want. I don't have the commute information, but oftentimes, on my machine, I'll have all the information about, what the traffic looks like, and I can always glance over to the side and see what that's looking like at any point in time. And again, it's a simple technology, but it sort of brings up the notion that you'd like to be able to collect all the sort of notification information and the things that you're doing within a work group into one place and be able to interact with it. And again, we found it to be very, very helpful in our work, and now some of the product groups are beginning to use it as well. Another technology we've developed we call iCam, and what we're really trying to do with that is to make it easier to have remote meetings. You all know that now when you think about filming a lecture, having a remote lecture or having a remote meeting, to do a really good job of it, you often have to have a cameraman. I mean, someone who's really monitoring what's happening and doing a good job of moving the camera around and sort of giving you a sense of what's happening during the presentation or during the meeting. What we've come up with is a technology that lets you get a full 360-degree view of a room from a single device. We call that a ring camera. Basically, what we've done is we've taken a series of very inexpensive cameras, put them around in a circle, and we're using computer vision technology to create what looks like a full 360-degree image. Effectively, what we're doing is stitching those images together, but doing it in a way that preserves the appropriate sense of perspective through the entire 360 degrees. And you can see here, these are three people sitting around a table, and you'll see the whole image. One of the things that you can do with this technology is effectively keep track of who's speaking. Here there's a little box around the head of those people that are speaking. So it knows who's speaking and where they are, and then we can have a separate image that we keep just of whoever is speaking or whoever is doing a presentation. Here's more of an example of how this might be used in a real meeting. You see a ring camera in the middle of the desk, and the application is able to keep track of both what's happening on a whiteboard. That's an image from a real whiteboard. The sort of panoramic view, and then there's a little box which represents the view of the particular individual that's speaking or going to the whiteboard at any point in time. So again, it's a way of automatically creating a working environment in which the people that are operating remotely can move their gaze around automatically to anyone that they want to see. They can see everything that's happening in the room at the same time, and it makes it much easier to interact in a remote way. So again, automated meeting interfaces. I mean, the key thing here is again, we want to create the sense of cinematography. We want to create the sense of realism that you get, when you watch a movie of something. I love these little messages that they keep sending me up here. You guys can't see it, of course. It's now saying the internet is back. If you want to try the answer demo, you can do it now. I may try that toward the end. We'll see how we do. But thank you for that information, whoever you are. Do you get the feeling that there's like forces acting upon us from the outside? Breaking down barriers between people and information. Here's another area that I think is really critical. I mean, we're not very far away. I mean, you're already seeing 160 gigabyte disk drives coming on the market. We're not very far away from terabyte disk drives coming on the market. In 2004, 2005, when someone goes out and buys a PC, I think there's a reasonable expectation that they could get a terabyte disk, a single hard drive, 3.5-inch disk that they can stick in their machine that'll hold a terabyte of data. To give you a sense of what you could store on a terabyte of data, you could keep every conversation you've ever had from the time you were born to the time you die on a terabyte of disk and still have room left over to index it. Okay? That's how much data. Now, for people who talk a lot, it'll be more filled up. For people who don't talk as much, the more taciturn people, they'll have a lot of space left over for other things. But the point here is that you're not very far from the point where individuals can begin to hold tremendous amounts of data and to manipulate that and to interact with it. And they're going to need the tools to process that information. Now, some of you probably know about the Terrace server. This was put up by our research group in about 4 years ago now. Boy, it seems like it wasn't that long ago, but I think it was 4 years ago that we did it. And it was the first time that anybody really taken a multi-terabyte database and put it out on the web for sort of average people to use. We decided to use images of the Earth's surface. We got our images from two sources. We got them from the US Geological Service. They fly airplanes at 10,000 feet and take 1 meter resolution images. And we got them from the Russian Space Agency, which is to say we got spy satellite images. And those were 1.5 meter resolution images. Here's an example of one of the Russian images. This is the pyramids at Giza. Here's the Microsoft campus, and this is an older picture in 1990. We now have updated images. In fact, we're constantly updating this website now. It was 3 terabytes when we got started. It's now over 17 terabytes of data, and we're continually adding more data to it, including topographical information and things of that sort. You notice there were a lot of trees on campus back then. Most of those trees are buildings now. Microsoft's grown a little bit. There's the Space Needle, so if you fly in, you can see the Space Needle, and this is roughly what it would look like. This picture just showed up in the press recently, which I thought was really funny. Somebody at ABC News embedded a message in this picture using steganography. But I think this is a cute picture. If nothing else, it shows you a lot of airplanes that aren't ever going to fly again, sitting in Arizona. And you can see them in various states of disrepair. This is one of my favorite pictures from the TerraServer site. And the reason I like this picture a lot, I don't know if you can see it very well, but this is the Vatican, and there's a bridge. It's really, I can't really point, but there's a bridge that crossing the river over into the Vatican. And if you look carefully, you can see there's a traffic accident on the bridge. It gives you a sense of what's happening there. Now, you can't actually see the people yelling at each other, because that gets below 1.5 meter resolution for people. But they're there. Okay, I lived in Italy for a year. I know the people are yelling at each other. So you get a sense of what's happening there. Now, the TerraServer started out, it was an enormous thing. We only used 4 gigabyte hard drives in the first version, so it took up a huge room. Now it's a much more compact device. It's using all of the latest versions of software, and it's been interesting to see how it's grown. As it's really gone from a small, relatively small by today's standards, 3 terabyte database to 17 terabytes, and it's continuing to grow as time goes on. The interesting thing about the TerraServer, in some sense, is that even though it was a website, we discovered that a lot of people were using it to actually get information. A lot of people were coming to us saying, we just want the data, from your website. We don't really want all the pictures and all the web pages. We just want the images. We just want the topographical information and the other kinds of information that you store there. So earlier this year, we actually took the site, and using a beta of VisualStudio.net, we put this site live on the internet, all available through SOAP interfaces and through VisualStudio.net. And in fact, this fall, MIT and a number of other universities have started using the Terra service, as we now refer to it, in teaching distributed systems courses. Again, using all the technologies that you guys have heard about all this week. And you can get access to the site as well. It's out there. Here's the full collection. I mean, we've got all the support in it for all the WSDL interfaces. You can program it to it in the standard with the standard VisualStudio.net tools. Basically, everything that you'd want to do is access is there. And amusingly enough, we put this site online over the summer. It's already being used in production now by the USDA. They're using it to extract information to make available to their field agents on their laptops that they then can take literally into the field with farmers to show them what's happening, what the situation is, and to be able to help them with soil conservation and crop management. The TerraServer spawned a number of other projects. Probably the single biggest one that's going on right now is something called the National Virtual Observatory, or the Sloan Digital Sky Survey. And we're working with the National Science Foundation, with Caltech, with Johns Hopkins, and a number of other organizations, universities and research organizations, to build what effectively is a virtual observatory, where in a sense, you can think of it as a terrace server looking out the other direction, where astronomers around the world and ordinary people will be able to get access to dozens of terabytes of astronomical data collected all around the world. And in fact, this site's been online for experimental use already, and a number of new astronomical events have been found by data mining against the site. And it's really the first time that people have been able to get access to this kind of information. And the exciting thing is to think about now, this isn't, I mean, you know, when you think about a 17 terabyte database today, it's still a fairly large thing. You know, again, by 2005, you're talking about something that you could literally put into a tower, tower PC, and that's where the technologies are going and where the opportunities are. I mentioned breaking down barriers between computers. WAN bandwidth is going up dramatically. I talked about the possibility of terahertz networks over the next 5 years. It's really dramatic. You know, we've been working hard within my research group to work with our product groups at Microsoft to make sure that Windows is the fastest networking platform on the planet. We hold what's called the Internet 2 LAN speed record, meaning that we've been able to drive desktop to desktop more data faster than anybody else with any other kind of computer. And literally, we're using desktop machines, and most other people are using much faster machines to do that. So that's been very exciting. And again, the opportunity, I think, exists to be able to literally, you know, take the kinds of technologies that you've been hearing about over the last week that are really directed at building a global distributed systems environment and really turn that into effectively a global computing environment where computation could reside almost anywhere. Lastly, I'm going to talk about breaking down barriers between the different aspects of your life. There's a little video here I'll show.
What would it be like if a computer was as smart as a person and as intuitive? What if a computer could learn simply by watching over time? What if your computer could be more like a human assistant? I'm really interested in the foundations of intelligence. What is intelligent reasoning, decision-making? Today, using a computer is more or less like driving a car or controlling a machine in your kitchen. You don't have the sense, typically, that the computer is reasoning the way a companion or a colleague might be reasoning about you. So I believe one of the foundations of intelligence is grappling with uncertainty in the world. If you think about it, every day people are faced with an enormous number of decisions under uncertainty. Well, computers have faced the same problem. In fact, they see even less of the world than we do. They have to continue to guess about how best to provide assistance, for example, in a user setting. What is the meaning of that word that I see in this document right now? What am I seeing right now? Should I help the user right now or wait patiently to understand more about the problem first? Is now a good time to send that information to the user? Which device should I use? Will that user have the cell phone with them right now? Or I think they might be at a desktop system somewhere. We've been working very hard to give computers new sensory abilities so they can hear, see, even feel what applications are being touched and how. We've been studying principles as well as applications of smart decision-making about information within the Notification Platform research project. It lets the user subscribe to multiple sources of information and decides if, when, and how to send messages to users. My computer knows that we're here having a conversation by listening to us, interacting. It knows whether I'm looking at you or at the computer by tracking my pose. It understands what's going on by considering the time of day and looking at my calendar. What did I tell my calendar I'd be doing today? But it considers all these things under uncertainty and fuses all this information together in a way to build a picture about what's going on. Make sense? What would it be like if computers understood when and how to interrupt you, considering what's up in your life, what your context is at the moment? Now, Priorities actually learns about which mail you would consider urgent versus non-urgent, whether you be at your desktop working on another application or in the world doing other things. It understands by looking at patterns of how you work with mail as to which messages are probably the important ones. Think about it, we're all Sherlock Holmes, sort of all the time. We're always integrating information, making guesses under uncertainty, building intuitions about what's really going on. We're in a situation now with computing that we're beginning to provide basic new forms of value by being smart about things and being intuitive. We believe that developing the right kind of machinery to balance that off in an elegant way will lead to great services for people.
So that's Eric Horvitz, who's heading up a lot of this work in our research organization. And just to reinforce some of the points that was made in that video, one of the things that we've been able to do is find ways of automatically prioritizing people's mail. And this is not just by looking at the mail. We're doing that. We're actually using natural language technology to try to extract from the mail the information that's there. But we're also doing things like looking at your org chart. Right? The people near you in the org chart are going to be more important. The guy right above you or the woman right above you is going to be more important than other people that are, say, cross-organization. We're looking at your schedule and trying to integrate that information. We're looking at what you've done in the past and learning from what you thought was important and what wasn't important. So priorities is an example of that. Again, it's a technology we've been using within the research group. As was mentioned in that video, it is a really way of automatically classifying information that comes in, letting you get a sense of what's higher priority, what's lower priority, so you can sort of manage your information. It also is really good at filtering out junk mail, and that's another critical part of it. Another thing that the same technology is useful for is, as was mentioned by Eric in the video, understanding when you're going to be in your office and when you're not. I mean, where are you at any given point in time? Collecting all the data that we know about you from your use of computers and various devices to help build a map of where you are and what you're likely to be doing so that we can help notify you in the most appropriate way, or perhaps notify people that you care about in terms of what they're doing. So one of the things that was mentioned there is this automatic availability setting. Here's an example where the system has looked at your schedule and understands your past behavior in interacting with your schedule to effectively predict that, for example, you're probably not going to be in your office for a certain period of time immediately after the talk that you're going to be going to or the meeting that you're going to go to. It knows that there's travel time, just like a good assistant would know that. And a good assistant would program travel time in to your schedule so that you wouldn't schedule back-to-back meetings when you couldn't be there. Well, this system is capable of doing that as well, and of providing targeted responses to people based on your availability and who those people are and who you want to notify in certain ways and who you don't. So here again, selective. Now, the earliest version of this technology actually going out on a product is already out there. It's something called our Outlook Mobile Manager, and that incorporates some of these technologies. And if you go out and if you get Outlook Mobile Manager, you can play with that. It understands some elements of being able to schedule messages and schedule notifications. But we're constantly improving that technology and really trying to build what amounts to a notification platform, working with the .NET team and thinking about this as a service that can be provided where we can collect many different sources of information, integrate those, use intelligence, and then use that to vector notifications to the appropriate people with the appropriate level of importance. So I'm just going to quickly show you some of the things that you can keep track of. Here, for example, the system even knows when you're in a meeting, when you're talking to someone, when you're away from your desk, and so forth. So I'm going to skip over this last piece, if I can push it a little far. There we go. And just finish up. But first, I will go back to that one demo. I think it's back up. Can you bring up this, the question answering? Okay. I just wanted to prove to you that if you say, where is Osama bin Laden hiding? It does actually say Mountain Fortress in Afghanistan. And you can ask it. I hope the network doesn't go back down again. You'll say, who's the head of Microsoft Research? And hopefully, if the network is up this time, and it's not just cached pages, we'll get a real answer. There you go. There's me. Roger Needham, by the way, heads up Microsoft Research Limited, which is our Cambridge Research Lab subsidiary. You can say things like, at least I was able to say this the other day. This is kind of a weird question because it's not really clear what the answer ought to be to this, but light, I think, is as good as anything else. That's probably as good an explanation of that. And then yesterday, just for fun again, I typed in, when did aliens first land on Earth? We'll see what it gives me today. Yesterday, I thought it gave me a pretty good answer. Yep, there you go, July 4th, 1997. Independence Day. I'm not sure we're really ready to sell this product yet, but it is awfully darn cute. You could have a great deal of fun just sitting there typing at it. So, like I was saying, we're at an inflection point. I think the key message I want to leave with you is that the next 10 years are going to be incredibly exciting. If you think of what's happening with the underlying technologies, the nanotechnologies, the MEMS technologies, when you think of what's happening in software, understanding of how to do natural language and speech, and when you think of the opportunities to be able to do data mining for vast amounts of data, a whole new range of applications are going to get enabled from that. And I think this is just the most exciting possible time. And I know in our industry, right now there's a certain amount of pessimism. People are saying, well, haven't computers done everything that they're going to do? You see these news articles, for reporters that basically seem to indicate that, well, it's all old hat now. Well, you ain't seen nothing yet, right? I mean, computing, the opportunity to bring new value to people, to create new value for people, is really just opening up over the next 10 years. And I think it's going to be just very, very exciting. I want to thank you all for being a good audience. I also want to just, as the last Microsoft executive that's actually speaking, I also want to thank you very much for being here and for coming. I know this is a very difficult time for a lot of people. The last couple of months have been hard, not just for our industry, but for the whole country. It's been a difficult time to travel. I know I've been doing some of it, and it's been hard. So I really appreciate the fact that you've come. I really think the future holds a lot of new opportunities for all of us. And again, I just want to give you my thanks. Thank you very much.
Well, that brings us to the close of the last general session of the last day of the 2001 Microsoft Professional Developers Conference. There are still 3 more sections of breakouts you can go to get some last-minute information about ASP.NET, .NET Services, Tablet PC, C#, C++, and other programming aspects. I've got a couple of last little announcements I want to give you. First off, I want to correct an announcement I gave at the beginning of the show today, and that is on the head-to-head game. The head-to-head game, I was incorrectly told closed at 2:30. It actually closes at noon today. So from 9:30 until noon is when the people are going to be staffing the head-to-head booth downstairs, and so that's the time frame that you can go down and give your answer to the cryptogram if you figured it out. Also, I'd like to let you know that we really find it important that you guys fill out the evals. There are evals available that you can fill out on the ComNet, so please take your time to go down there and fill those out, because we do definitely read that information, and we use that to take and determine what we're going to do for the next PDC. We're already in the planning stages for what we're going to do and where we're going to be for the next PDC, and so your information and your input is extremely important for that. So until the next time we join you at the PDC, the next time you come down to listen to information about what Microsoft technologies are, I'd like to thank you for coming, and we'll see you on the web.